is Math 118, Section 6.1. The section is called Multiplying and Dividing Rational Expressions. What makes them rational expressions is that they are fractions. I'm going to take two examples that I did on the board and combine them into one great big problem. The quantity x plus 3 squared over x squared minus 9 times 2x minus 6 over 5x divided by x squared plus 7x plus 12 over x times 12 y to the third over 5y squared minus 5 divided by 6 over 1 minus y. So these are all rational expressions. They're all fractions. The numerators and denominators contain variables in them. In order to simplify this problem, you're going to be doing it by factoring. In this first fraction, x plus 3 squared is the same thing as x plus 3 times x plus 3. So write it twice. In the denominator, x squared minus 9, that's called the difference of two squares. That can be factored into x plus 3 times x minus 3. Now, the next fraction, the numerator is 2x minus 6. The only thing I can factor there would be a greatest common factor of 2, and then I'm left with x minus 3. And the denominator is just 5x. Nothing to factor there, but keep in mind that 5x is the same thing as 5 times x. After that comes a divided by sign. When you have a divided by sign, change it to multiplication, and then flip the fraction that comes after that over. So where the x was in the denominator before, I've put it in the top. And the numerator, this trinomial, x squared plus 7x plus 12, I'm going to put in the bottom, and I'm going to factor it at the same time. For trinomial, the method I use is called trial and error. X times x is x squared. What times what is 12? You have a bunch of things to try, but for the sake of time, I'm going to try 3 times 4 because I know that works. It's a plus 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 pattern, but with all trinomials, even if you think you know it's going to work, still check by looking at the inside and the outside, or the smile and the chin, and make sure they add up to your middle term, which was 7x. Works. Okay, good. Continue. Now I have 12y to the third, which is the same thing as 12 times y to the third, and that's over 5y squared minus 5. I can factor out a 5, and I'm left with y squared minus 1. Oh, I'm going to be able to factor this again. Y squared minus 1 is the difference of two squares. That becomes y plus 1, y minus 1. It's looking a little messy, but we'll fix it in a minute. After that comes a divided by sign. Change that to multiplication. And invert or flip over the fraction that comes after it. So the 6 moves to the bottom, the 1 minus y moves to the top. So let me write this whole thing down again. X plus 3, x x plus 3 over x plus 3, x minus 3 times 2. That's just a single 2. He's hanging out there all by himself. See how he doesn't belong to any of these quantities, any of these nice little blobs? Actually, the 5 and this x is also. They're single individual little factors. They don't belong to any little families, any little groups. Then I have x, another single guy, over a little x plus 3 family. That's a quantity, cannot be broken up, and another x plus 4, little family quantity there. Then I have 12 y to the third. That's an individual 12 and a little y to the third. And that's over 5 y plus 1 times y minus 1. And that is times 1 minus y. As soon as you start seeing plus signs and minus signs, there are actually little quantities there, or little groups, or little families, and I put parentheses around them to kind of help myself keep things straight. So look at this whole big problem now we have here. It's all multiplication. Everything's been factored, so the next step is the most fun step of all. Because what you get to do now is when you find anything in the top that matches with anything in the bottom, you can cancel them out, or I call it slashing away. Start right here at the beginning, that x plus 3 and that x plus 3. Gone. This x plus 3 and that x plus 3. Gone. Now see, underneath this x plus 3 was an x minus 3. They are not the same term. Just a little tiny difference. Plus sign versus a minus sign will change the entire quantity. Cannot be canceled. I do have an x minus 3 over here, though, can cancel with this x minus 3. Looking around, I have a single x, cancels with that single x. What else have I got? See this 6 way down here on the end? 6 goes into 12 2 times. Now, that 2 and both 2's are in the numerators, both 5's are in the denominators. They're not canceling each other out. You get to keep them. The other thing I wanted to point out, down at the end of this problem, I have a 1 minus y on the top and a y minus 1 on the bottom. These are called opposites. They're not exactly the same. They're opposites. But you are allowed to cancel opposites as long as you put a minus 1 somewhere in your answer. Remember, the opposites are like, say, what's 8 minus 5 over 5 minus 8? Same numbers, opposites position. 8 minus 5 is 3. 5 minus 8 is a minus 3. So they're the same number, opposite signs equals a minus 1. That's where the minus 1 comes from. Okay, so my answer is going to be the 2 times the other 2 times the y to the third times the minus 1. I think I've gathered everything in the numerator. Just let me look real quick. There's the 2, and there's the other 2, and there's the y to the third, and there's the minus 1. Yeah, that's everyone upstairs. Downstairs, I have a 5, an x plus 4 quantity, little family there, can't break them up, another 5, and a y plus 1. Okay, just kind of cleaning this up a little bit then. My final answer is minus 4 y to the third. So I can multiply those together, the 2, the minus 1. That's where the minus 4 came from. And in the denominator, I've got 25. Multiply those two 5's together. And then my x plus 4 quantity and my y plus 1 quantity. And you're stuck with that. That's it. That's the final answer. I'll put a circle around it.